Hello, we will begin shortly.
Hello.
How are you?
Fine, how are you?
Doing just fine. I'm starting to commute into the office, and the downside to that is I have not developed my systems, and so I've forgotten my badge.
Okay.
In our lobby. Getting back into the swing of things.
Where do you
work? Go ahead.
Where about?
What was your question?
Where are you located at?
Oh, I live in Portland, Oregon.
Portland, Oregon, okay.
What about you?
In Germany.
Oh, nice. What part?
Southern part. Close to Mannheim, if you know Mannheim, Heidelberg.
Okay, cool. Is it starting to look dreary there now? Or what's the weather like?
Yeah, it's still pretty warm. 18 Celsius today.
Cool.
But it's getting a bit colder now.
Mm-hmm. It's been unseasonably warm here. It's been 85 Fahrenheit, which is like very nice weather, summer-ish.
Yeah, 85 is pretty warm.
I'm sorry, can you say that again?
Yeah, 85 is pretty warm.
Yeah. I have so not only am I locked out of my office, there's elevator maintenance going on. And so there's people hammering an elevator.
Okay, great. That's two only today.
Yeah.
I haven't joined for quite a long time. I finally managed again.
That's great. Well, we're going to hear about Fresca when those folks show up. It's exciting. We were supposed to do that 2 weeks ago, but Zoom had issues, so we called it.
Okay.
Yeah.
How busy were the past meetings? Except the last one, which was canceled due to Zoom meeting and Zoom issues.
Yeah, we hover around 10 folks who show up.
Okay.
I'm surprised that it's so quiet here this morning.
Okay, yeah, strange.
And also that our speakers aren't here. But I'm sure they'll get here. So what do you do in Germany?
Yeah, I work with SAP.
Okay.
Yeah.
I think they do statistics.
Pardon?
Statistics software or not?
No, business software.
Okay. I've never worked with SAP, and someone recently, SAS. SAS.
Yeah, that's different. SAS is different.
Yeah, okay, cool. That's a fairly large company from my understanding.
Yeah, around about 100,000 people.
Yeah, wow.
A bit more by now.
Mm-hmm. Are they fairly centered in Germany or?
All over the globe. They are originally founded in Germany, close by here, but offices all over. Right? We have several offices in the US, East Coast, West Coast.
Yeah.
India, China. All over the globe.
That's cool.
South Africa, Israel.
eBay has a handful of offices, but most development is in San Jose. And there's a big office in Shanghai. And we have a bunch of remote folks everywhere, but yeah. All right, I might ping our speakers to see, validate they're going to show up. 1 second.
Hey, Justin. Yes, I'm here.
Hi, Parth. How are you?
Okay, I was talking on mute. Yep, just getting set up here. Sorry about that. Second.
Morning, Tim.
Hey, how's it going?
Going well. How are you?
Not too bad, thanks. Sorry
Just
about
getting
being late.
Oh, no worries. We're getting a little bit of a late start all around. No.
Sorry about this. It's having a quick issue trying to get in on the server. For some reason, my key is being denied. Why?
Ooh.
Oh, I see what's wrong. Okay, here we go. Should work now. Okay, there we go. Okay.
Cool. And you can take it away whenever you're ready. We're, I think, all excited to hear more about Fresca and how it works and all the other good stuff.
Awesome. Yes. Okay. So let me get started. So actually, real quick before I bring this up, I apologize. Like this, I kind of blanked that this meeting is actually happening at this time, so I was not fully prepared. So I apologize for the delay. It's bringing up this diagram here.
Do you want me to take the first part while I get the login stuff working, or?
Sure. No, I was just going to walk through the diagram, like the architecture kind of thing, just to show off what it was. And right, I have it here. Okay. Yes. There we go. Okay. So let me stop sharing my screen. Reshare again. All right. Can everybody see this?
Yes.
Okay. Perfect. So before I kind of went into the demo itself, I kind of wanted to talk about like what we're trying to build out here for Fresca. So this is based off the CNCF reference architecture for the secure supply chain. So what we tried to do is implement all the different components that were there that was recommended by that white paper. So for example, there's a central build environment, right? So this is going to be, in this case, we're using Tecton pipelines. The pipeline observer, we're using Tecton chains. We have workload and node attestation with an identity service, right? So that's kind of going to be coming from Spire. Admission controller right here is going to be Kyverno and so forth, right? So what we try to do is we try to glue everything together. So what Fresca is we try to make it so that it's seamless for the developers. So as they're actually going through and trying to build out their the different projects, we're trying to make it so that the security aspect of it is kind of given to them, right? So that they don't have to actually think about it. Basically, they kind of follow their normal routine of, hey, I push some code into my Git repository, and it's it does this thing. I get an artifact or an image at the end of it, right? But what happens in between all of this, right, is you're getting all that security. You're getting that whole the tamper-proof. You're getting the the attestations generated automatically. You're getting all that kind of information created for you, and getting all the security kind of built in without the developer having to do anything or think about anything. So that was our goal, is to make sure that we kind of make it so that it's kind of seamless for the developers, and we can easily they can do their work. So what I'll show here is I'll show off the different pieces, and I'll kind of walk through those. I'll show you a quick demo and the things that it kind of protects against. So the first thing I'll show off is in terms of like what the bad things are, right? So for example, is there a question? Okay.
Hey Bart, I was just gonna just quickly, I think, orient a little bit. So before we get into the sorts of problems that it's protecting against, ultimately at the highest level, Fresca is doing, I think, two big things. One is just a set of build pipelines, visibility, and tools to be secure in your development. It's trying to provide and it's trying to provide a set of guardrails and abstractions to make sure that you stay that way, right? So that's really the ultimate goal that it's trying to hit. Be secure in your build, and don't let you do insecure things. All with the fundamental purpose to not get in the way of the developer and not have this be a thing that they're constantly worried about. So it's trying to do those things in an easy way. So when Parth is jumping in to talk about some of the bad things can happen, this is where you start to hear, or I'm sure you all are familiar with this, having been in these sorts of meetings, all the sorts of supply chain attacks that can occur. It's ultimately trying to make it easy to prevent those kinds of certain categories of those things from occurring, or allow you to react quickly when they do. Hope that made sense. Go ahead, Parth.
Yeah. So like Tim is saying, we try to make it so that we kind of abstract out all those complexities, right? So we're using Q to kind of abstract out that layer so that the developers can just provide some kind of configuration, and then the rest of it's kind of taken care of, right? Because of the guardrails are in place, it's going to automatically have them flow through a specific pipeline that's predefined based on policy, based on the sign off from the security team and so forth. So it's all kind of done for you. So let me switch over to the demo piece here. Okay. So let me show off here. Is this readable? Is it too small? Should I make it a little bit bigger?
I think that looks fine.
Okay. So what I'm going to show off. So real quick, in terms of the different components, right? We talked about Tecton pipelines. It's the actual build environment. Tecton changes that pipeline observer. We have the Spire agents running here, Spire server and Spire agent. I won't go into too much detail in exactly how Spire is working in this case. If you're interested, we can talk about it more later on. But basically, that's the one that's kind of giving that short-lived certificates in order for it to allow to identify if as the build is going through the pipeline, has it been tampered with, right? It has that ability to check to see that the results are the way they're supposed to be. At the same time, the artifact you want it to be created at the end is the one that got created, right? So you have complete trust in your pipeline. So that's what Spire is allowing you to do, along with Tecton chains and along with pipeline. So it's all kind of integrated all together. We also have Kyverno running here, which is that emission controller piece. So this is the one that's checking to make sure that there are attestations associated with the images you're pulling in. Are they signed with proper signatures that you trust, and so forth, right? So all these pieces are all kind of working together to make sure that when you ingest something and when you output something, that's all trusted. And finally, Vault is also in here, and that's going to be used for your long-term signing keys, right? So Spire is the short-term signing key. Vault is the one that's storing your long-term, your actual signing keys, right? That's going to sign your artifacts at the end. So Chains actually is automatically integrated with Vault, so it has the ability to actually authenticate to Vault, and using a transitive plugin, it actually signs the artifact and publishes to a registry. Okay, so the first thing I'll kind of show off here is, and hope this all works because I have not tested this in a while. So first thing I'm going to show off is like, how does this kind of look in terms of running, like an unsigned? What's going to happen if I try to create an unsigned image? So what I'm doing here is I'm just running build packs locally, and what I'm pushing it to ECR. And this is basically like, for example, I didn't go through the proper procedures of creating an image, right? I didn't go through my Fresca, right? I didn't go through Fresca and I built something. What would happen? Would the policy manager, the admission controller catch this and not allow it to run in a production environment? So that's what I'm trying to show here, is that it's going to, once it does this, it's going to show that, because it's not properly signed, because it does not have any attestations associated with it, it's not going to be allowed to run in that environment.
While that's going, is any questions? Is the general idea making sense? Want us to dig into anything else while this is cooking in the background?
I think that generally makes sense to me. I'm a little curious, like, where the attestations are like being looked for.
So the attestations get, so Kyverno has the ability to pull them down from OCI. So they're stored in OCI along with the image.
Got it, thank you.
Yeah, so that's part of what the pipelines are doing, is that as they're building, generating all the attestations, generating the S1, signing that all, pushing that into OCI alongside the artifacts. And then the Kyverno policies are basically set up to go pull those down, look for those, inspect them, and then just ensure that everything's matched up. So if your signatures are not matching up, or your hashes aren't matching up, or anything isn't quite right, Kyverno will stop that from running. And again, those policies are editable, but this one that he's showing there is basically just saying that, hey, that has to have a signature from, let's say, that only the build pipeline can actually provide you, so that you can't do something like squat on the repository and just upload another copy of a similarly named image.
Do you also store those policies in OCI for the Tecton chain stuff?
I'm sorry, can you repeat the question?
Yeah, you said that you're using other attestations and not just container signing.
Yes.
Are those also being stored alongside the container?
Correct. Yes. So the signature and as well as the attestation is both stored along with the image in OCI. And I can show that off in the OCI. Actually, there's been a PR and an update to the OCI spec. I think it has the ability now to differentiate between like a signature object versus like an attestation object. So before, it was going off of the, like, what is it? Like, if it's a dot signature or dot attestation, that's what it's kind of going off to, searching for that kind of an object in the OCI registry. Now it's made official, and I think that should be done by the end of the year, so that it has that ability, so that it can actually, it's an actual signature object and an actual attestation object that's in the OCI registry, so you can actually go query for that.
Cool, thank you.
Yep. So right here, so kind of showing kind of what Tim was saying, right? So Kyverno has the ability to have the policies in place, right? In this case, Fresca has a lot of policies built in, and that's what we want, right? We want to make sure it's very easy. So based off like what information you provide, basically through that abstraction level, we create the policies for you, and they get kind of placed in here. And you can see that the signature is no longer valid because there's no signature at all associated with this because I built this manually. At the same time, there's no attestation associated with it. So now it's going to deny this from running in a production environment. And similarly, if you're running this in another cluster, you could do something similar. Okay, so the next piece I wanted to show is the piece where I'm a malicious admin in my Kubernetes cluster, and I want to sabotage the build as it's running. So if you remember, I spoke about Spire, and it has the ability to do the short-lived certificates and signing. So that gives us the ability to check if something has been tampered with, right? So what I'm going to, this kind of a short demo here is what I'm going to show is as the pipeline is running, and it's this long running task. So you can, for example, you can imagine a pipeline that's taking maybe, let's say, a minute or so to complete, or less than that, and some kind of an automated process, or someone manually comes in and tries to modify something like, oh, I see that you're using Alpine image or something, right, to build this image. I want to change that with Alpine also, but something else that I incorporated into this Alpine image. I want to use that instead. So as the pipeline is running, I want to change the image that's actually going to be used to build the artifact. And so what this does is, what this is going to show is that Fresca will catch that from happening. So as it's actually running, it's going to catch that, oh, something has changed, right? Something has changed in my task run or pipeline run, something has changed. So now it's going to invalidate the whole pipeline. So down here, you see what happened as it was running. You get an internal error saying that the task run status condition not verified. So Spire could not verify the results, and it also couldn't verify the conditions. So I won't go into much detail into exactly how Spire and Tecton chains and Tecton pipelines kind of all work together. That's a whole separate discussion that I can go much deeper into. But just a real quick overview is yes, it's checking to see the task runs themselves. The task runs are signed. So if as results are created between tasks, those are also signed as they're passed between tasks. At the same time, the status of the overall task run is also being verified. So down here, if I look, so initially, so I'll show here is the long running. So the long running task was very, very simple. And all it was doing was just running a hello world, but it was using Ubuntu in this image. So if I scroll up here now, it got changed to not Ubuntu, right? So as it was running, my script kind of went in and modified the image to be something different. And because it changed midway through the pipeline run, right? Spire caught this, Spire, Tecton chains, and pipelines caught this as being something nefarious and saying well, this is not expected. This is not something that I expected to change. And that's why it invalidated the whole result. Does that make sense so far? So you can see up here, if you're familiar with Tecton, it retried. Tecton chains is the one that does the signing usually. So it retried 3 times to sign the image, right? But because it was invalidated, because it said, oh, well, I can't trust this artifact, so it didn't sign the image. So for example, if I try to, even if it created some kind of an image, for example, right? Even if this passed and it created some kind of image and pushed it to OCI, it would not have a signature associated with it. It would not have an attestation associated with it. So I would again fall into the same category as this, right? So then again, I can't run this in my production environment because it doesn't meet the policy. Any questions? Cool. The Spire piece, oh, go ahead.
Just saying that's cool.
Awesome. Yeah, so if you're interested more, we can, in a later meeting or something, we can go deeper into the whole Spire Tecton integration, but I'll keep moving for now. Okay, so now these are all the bad things, right? These are the things that it protects against. what would a normal operation look like? You know, I'm a developer. I just want to push my code, right? I don't care about what's happening in the background. I don't care about security. I want to make it to be easy and painless for me. So how does that work? How does the actual good scenario kind of work now, right? So what I'm going to do is I'm going to trigger a build in GitHub. So all I'm doing is just creating a new pull request. And what that does is that's going to trigger an event in Fresca. So what this is going to do is I'm just watching for it now. So it's going to trigger the pipeline to run, basically. So the pipeline has already been defined. There's some trigger sets. So there's a webhook I created in GitHub. So what this does is that it initiates that pipeline, feeds it in some initial environment variables. What kind of commit it's using and so forth, right? And then it's going to launch the build. So it's going to do git clone. It's it does a variety of things. It's going to build. It's going to do. You can do unit testing, right? You create the actual build. We'll create the SBOM and so forth. All that kind of stuff is all contained within the pipeline. And at the end, because it's going to be right, because nothing tampered with it, because I can verify all the results and so forth. Change is going to come along and do the signing. It's going to sign it, create the attestation for it, and then push all that stuff into an OCI registry for me.
Yeah, again, while that's cooking, one of the things we thought would be interesting for this group is really what Fresca is doing is tying together a whole bunch of things, right? It's really trying to make stuff play together, and we're using Qlang to do a lot of that abstraction for you. So it's trying to make it so you don't have to be an expert in Spire and Tecton and chains and all those things that can be a little bit gnarly to wire up yourself. So that it's consumable for a normal developer who just wants the nice things but doesn't have to be an expert in them, right? So that's really where we thought that might be an interesting angle. So you can see as a dev, you're just following a normal dev flow. You don't have to be concerned about the details.
Right. Okay, so the pipeline completed. So I'm going to verify, right? I'm going to verify that everything looks good and, and that I have the proper signatures. So we are using, so let me up here real quick. So this is just the pipeline results. I just want to show this real quick, what a good use case would look like. So up here, if you remember in the bad use case where I, modified that image to be not Ubuntu, this failed completely, right? So now it's saying, well, the task run results are all verified, right? They're all successfully signed and verified against Spire. So that's what this is showing. And then up here, you see that there's another annotation for the status. Again, it's not showing any kind of errors. So that means that, it expected, everything went as expected and nothing kind of interfered with the actual build, the build process. And then scrolling up here, you see Tecton chains. Finally, right, because again, it does verification to check to see that did anything interfere, everything looks good, then it's going to do, okay, I signed it, right, using that, the key that I have in Vault, right, it has the ability to automatically log into Vault via Spire, right, and then use a transitive plugin to sign the artifact, as well as create the attestation. So these are the two things that you see here. So Change has the ability to actually append the payload, right, which is the attestation object itself, as well as a signature to the annotation in the Kubernetes object. At the same time, I'll push it up to OCI. So it did both in this case. So that's what to show there. And then I think there was a question in terms of, what does this look like in terms of OCI, right? If I scroll down here, you can see that there's an image, right? This is the image that we created, which is the commit hash of the Git repo, as well as you can see the .tt that's the attestation and the signature. So you can see I run this multiple times, so there's a bunch of them in here. So that's what this is. So there's the attestation and the signature associated with it. And here's that bad Python one that I made initially before, right, which I didn't sign. So that's in here also. And then coming down here, where we can use cosign to validate that everything is signed. So cosign, kind of goes in and validates the signatures, and you can see that verification was done to that image. And you can see that's the same image tag up here for that Python hello world. So it verifies the signature. At the same time, it verifies that the attestation is also signed. So that's what all that information is down here. So lastly, what does this payload actually look like, right? This is a bunch of base64 encoded information. So if we take a look at this, what is basically is that it's creating a salsa attestation, right? So it's creating a salsa attestation, and what was the name of the image that got created? What was the hash? And then what is the different parameters and build steps that it kind of went through, right? So we can use this information and feed it into other tools that can actually ingest this information and give us a bigger picture and exactly what's happening. At the same time, right, Kyverno, the mission controller, is actually looking at this information and validating it, right? So you can validate, yes, there's an attestation associated with it. You can actually check specific properties. I want to be like, oh, I want to check to see that it got built by Tecton Chains, right? It got signed by Tecton Chains. If it's been signed by something else, another builder that I don't expect to be in my environment, right? Then I'm going to invalidate that also. So I'm not going to allow that to run in my production environment. So it has the ability to check various components or various pieces of the attestation also. So this is the salsa attestation that gets generated by Chains. The other thing we're trying to work on, that I'm working on getting it implemented, is also creating a runtime attestation. And I don't have this in the demo at this point, but basically what this would do is create another attestation. Apart from the salsa attestation, there would be another runtime attestation, which uses eBPF, right? So you can see exactly what happened at runtime for your actual build, right? You can see the different processes that ran. Did it try to connect to the internet, right? If I see that it's trying to connect to the internet, then I don't expect that, then I want to catch that. So it's going to give you that kind of information in an attestation format. And again, you can have Kyverno check for that kind of information. If I didn't expect it to ever reach out to the internet and I see a call, TCP connect or something being made in my attestation, then I know something went wrong, right? Then I can just, again, I'd be like, oh, I'm not going to allow this to run because I see a TCP call, TCP connect call being made, which should not have happened, right? So you can verify those kind of things. And again, all this information, our goal is to kind of push it into another tool that we're trying to work on. Is called Guac, so that we can actually have a visualization and make better decisions on what we want to push into a production environment. Any questions?
I have two questions. One is about those SHAs, those checksums that you showed for the various different builds that you've done in OCI.
Yes. Yeah. And
the other one is about what happens in production, in case I forget. So you have a bunch of different attestations there for what I believe to be different versions of the software. Is that true?
So they are different builds of the same repo. So it's basically this one right here.
Yeah. And
they're different builds of it.
So over time, okay, so the primary key, so to speak, is that last hash. And then there are those number of builds against that hash. Got it.
Yes.
Cool.
Yeah. And they're based off the digest, right? So it's based off they're associated with the digest of the actual build, so of this actual image. And that's how it associates with the attestation and the signatures. So that's how it knows, like, oh, even if I have, so for example, I rebuild this to the exact same tag, right? But I don't include a signature and attestation. Now it's not, even though there are attestations and signatures in this OCI registry, right? It's still going to invalidate that because now, right? Because the attestation and signature are associated with that digest. Now the digest isn't matched.
What is the digest generated from?
So when you create the image, right, it creates a digest in terms of what the layers and everything that it used to create the actual image, right? That's what that is.
Got it. Cool.
Yeah.
And Go ahead.
Oh, I was gonna say, and some of that's gonna change now that the OCI distribution and image spec changes have come through. So some of this stuff will actually be encoded in the manifest of the OCI itself. So it'll make it a lot easier to not have to, right now SIG store has to name it essentially, the digest.sig or digest.att, because there's not a great way to, in OCI to sort of say, hey, this is an attestation associated with this layer, or a signature associated with this layer. But in the future, that will all sort of be encoded more in the OCI manifest.
Cool.
Yep, that's the same point that I brought up initially.
The runtime, the production runtime question was, for the stuff that Fresca does, is that basically, does it stop when it hits production? Does like the system stop caring, or do we like periodically recheck the attestations, or is there a way to, I don't know, do things along that axis?
So our goal, I think, go ahead, Mike.
Oh yeah. So I could talk to that a little bit. So ideally, as this sort of continues to progress, we see that sort of thing being kind of like the Google style binary authorization model. So like Fresca right now is very much focused on purely the build piece. And then the idea would be, when you go to production, you say, hey, does it have a salsa attestation? Does it have a run? Does it have a runtime attestation? Does it have all these other things? If it does, we're going to give it, and no vulnerabilities. Does it have an SBOM and a signed SBOM and all that good stuff? And if the answer is yes, it would get, some sort of stamp. There's a few reasons for that. One reason is just doing the ongoing, like if you have to say, hey, let me look at the SBOM every single time the image, any single time the workload scales up or scales down or whatever, that can get quite expensive. But there's also other things that you want to do as well, which is like, I want to add a snapshot in time, be able to say, I looked at the list of CVEs, ones that don't have vexes or whatever. This is what I saw. And so we saw no known CVEs or whatever. It's good to go for 2 weeks. And then if 2 weeks later, there's known CVEs, you need to, readdress it. So that's kind of where we also sort of are looking at a couple of different groups and working with them to see what we can do from that sort of binary authorization piece that, you can almost have it automatically re-sign off production authorization. And then if it can't, it would essentially alert the build system and potentially trigger a new build, trigger stuff like, oh, okay, well, there's a known CVE, and either inform somebody that, they need to fix this, or if it's something as simple as like, this could be a dependabot kind of fix, then, maybe try that out, like tell Fresca to build against a newer version of a dependency. And if everything looks good again, great, but at least for the time being, we probably anticipate that being at least somewhat manual, where folks will have to go in and say, they'll at least get alerted that, hey, something has gone wrong. And then they'll have to make those updates in order to sort of keep that authorization going.
Very cool.
Any other questions? Yeah, I mean, I think if there's interest, I can speak more about it later in terms of the Spire components and how they kind of talk together. We did a whole open source summit talk on just that piece. So that's why I didn't want to bring it up here, because it's a very, it's by itself, it's going to take another like 40 minutes to talk about. So it's a very involved conversation. There's a lot of stuff going on behind the scenes. But that's the good part about Fresca, right? Is that everything is behind the scenes. You don't have to care about it, right? It's going to do all registration and everything for you, right? So the signing the short-term keys and throwing the short-term keys away and everything. It's going to do everything for you. So,
yeah, and just a couple of things to highlight there is some of this stuff will also change as some of the things come out of the CD Foundation, right? Where we're keeping an eye on, the supply chain security, the supply chain maturity model. We're keeping an eye on also the stuff like CD events. CD events could potentially also make stuff like Fresca significantly more pluggable, where the idea would be Fresca, potentially we see a future where Fresca could be more of the abstraction layer that then sort of, knows how to deal with the different events and ensuring that those events are coming in securely, ensuring that, if an event gets sent out to trigger a potential build, is the thing that's actually running that build done in a way that would, is SALSA compliant, is potentially, CNCF best practices compliant, CD Foundation compliant, and so on. And if it is, then, Fresca would be the thing that could help sign off on those and create attestations of those things so that you can have like nice flexibility where, in dev, we don't need to have all those attestations necessarily. And we don't need to go through all those checks, especially if some of those checks might take a while or they're expensive or whatever. But at least when you're ready to go into production, did all those things actually happen? Were they orchestrated by something that we trust? Did the workloads actually happen in the way that we trust? Or do we also know that, did a administrator of any of these things, right? Like the stuff that Parth had shown off a little bit with the Spiffy Spire stuff is like, that would detect if a, administrator with authorization messed with a build, right? Which is one of the key things, and one of the things that folks have brought up a few times with the supply chain attacks is that a lot of times it's either, an internal actor who makes a mistake and leaves something open, or they actually are a bad actor. They become malicious, and they do something nefarious, and that becomes very, very hard to detect because, hey, this is a person who has admin access or privileged access to a system. The Spire stuff can detect that. And then also, with the stuff that Parth was mentioning about eventually the workload, the runtime attestations, is some of that stuff is also like, if somebody has access to the internals of the build or has access at the host level, at some level, they've compromised the host. Can you actually begin to detect what's happening there? Is it trying to reach out to malware.com and those sorts of things as well?
Very cool.
Yeah, I think that covers it for Fresca. Again, if you want to follow up, we can link the repo, or feel free to ping us on Slack, or happy to chat about this whenever anybody is curious.
And you're on the CDF Slack, is that right?
Yep. Well, at least Parth and I are. I'm not sure about Tim yet.
Yeah, I'm there.
Perfect. Well, thanks so much for taking the time to chat with us today.
Thank you. Yeah.
In 2 weeks from now, on the 20th, we're going to be hearing from Kubevela, which is a CNCF project around making hybrid multi-cloud environments, deploying there much easier and nice, which, as someone who lives on-prem, that is, I'm excited. Yeah, and I don't think we have any outstanding action items that I'm aware of, Melissa. And so I think folks get a 15-minute refund on the rest of their day, and hope everyone has a good remainder of your day, depending on what time you're in.
Thank you. Thank you for allowing us to present here. Appreciate it.
Thank you very much. We'll get this posted up on the YouTube channel as well, so you'll be able to reference it if anyone else is interested. And I don't know, we'll do some tweeting about it too. I find this really intriguing and very important work being done, especially with supply chain issues and being on the developer side of things. I totally understand the overwhelming amount of information you need to know to protect everything all the way through to production. So this is awesome.
Right. Thank you.
Thanks all.
Everybody, appreciate it. Bye.
Thank you.